Good afternoon, Brave New World, or in this case, I should probably say, good evening. Good evening, Brave New World. It's Joshua again here with a brand new video in which I'm going to talk about one topic which is totally fascinating to me and that is totally connected to the particular, to the particular filter that I'm using in order to record this video. Alright? The following video that I'm going to do right now, that I'm going to make or film right now, has to do with a topic that I find totally fascinating and that I totally enjoy and I consider necessary and worth learning. Let's talk a little bit about astronomy. Alright, a friend of mine asked me to select the number 13, so let's discuss the following thing about the mass of the Earth. Alright, using the words of Isaac Asimov himself, let's answer the following question. Ring. What is the mass of the Earth? Welcome to this particular section that we should call Astronomy Support. Alright? Welcome to this particular section that we might as well call Astronomy Support. Alright? Astronomy Support. Why not? Let's call it that way. Alright? Before we even get started, we might as well clarify that the following question was again, what is the mass of the Earth? Using the wise and smart words of Mr. Isaac Asimov. And by the way, by doing this, I'm totally throwing some crap and I'm totally throwing some dirt to the shoes and faces of flat earthers. You guys are a total disgrace to humankind. You are a total disgrace and I can't believe I get to share air with you guys. Yes, that was an insult. That was an insult totally directed to people who don't share facts. No. That was an insult directed to people who don't care about facts and they just care about respecting the opinion of others, when in fact there is a tiny difference. There is a really narrow line between opinion and fact. So, the words of Mr. Asimov start like this. Question number 13. What is the mass of the Earth? Now, the question of the Earth's mass poses a problem indeed. We can measure the inertial mass of the Earth because it is so massive that we can't produce a force that will alter its motion in any measurable way. What's the meaning of that? It means that it is impossible to literally grab the Earth and set it on a weight measuring machine. What's more, we can measure the gravitational mass of the Earth because there is no way of weighting it. But you really don't have to weigh the Earth. This kind of makes me think about this phrase attributed to Stephen Hawking that says, it must be really boring to be God. Why? Because you don't have anything to discover. Nothing is new to you. If you take an ordinary object and measure its gravitational pull at a certain distance, you can then compare it to the gravitational force produced by the Earth at the much greater distance of its center to its surface. I'm not sure I got that, so let us listen to it one more time. It goes like this. If you take an ordinary object and measure its gravitational pull at a certain distance, you can then compare it to the gravitational force produced by the Earth and the much greater distance of its center to its surface. If you know the mass of the ordinary object, you can then calculate the mass of the Earth. How fascinating is that? To all the people watching, again, the question that we are going to answer would be... My cat is being silly. The question that we are answering is, what is the mass of the Earth? The trouble is that gravitation is such an incredibly weak force that it shows up in quantity only with a huge object. We think of gravity as something forceful enough to kill. But that's only because we associate it with the tremendous Earth. An ordinary object like a lump of iron produces so small a gravitational pull that it can be measured for real. Or, at least, it would so seem. There was this British scientist, Henry Cavendish, born in 1731 and died in 1810, tackled this problem in 1798. He suspended a light rod by a wire attached to its center, and at each end of the rod he attached a small lead bulb. Again, my cats are being silly. What happened to that one? Well, again, he suspended a light rod by a wire attached to its center, and at each end of the rod he attached a small lead bulb. The rod could twist freely about the wire in such a way that a small force applied to the bolts would cause the apparatus to move. Thus, Cavendish was able to measure how much twisting was caused by various small forces. He then brought two large metal bolts near the two small bolts, one on either side. The force of gravity between large bolts and the small bolts twisted the wire slightly, and from the extent of the twist, Cavendish calculated the gravitational force between the two pairs of bolts. He knew the distance between them, center to center, and the mass of each. He also knew the value of the much greater force produced by the Earth on the same light bolts at the distance between the center of the Earth and its surface. From the difference in the strength of the gravitational pull, he could calculate the mass of the Earth. Let us pay attention in particular to that specific line that says, from the difference in strength of the gravitational pull, he could elaborate the mass of the Earth. He decided that the Earth's mass was equal to 6 multiplied by 10 added to the 24th. I don't know how to read this number. In Spanish it would be something like 6 multiplied by 6 expanded to the 24th potence. I'm not sure. Oh my god. 6 and 24 zeros. 6 and 24 zeros kilograms. What's that? 24 zeros. Basically, the mass of the Earth has a number 6 and 24 zeros in it. Wow. That's 6 million billion. Oh my god, that's 6 million billion kilograms, or 3.7 million billion pounds. Who cares about pounds? I'm serious. Who cares about pounds other than Americans? Huh? Sure, Americans are amazing people, and I'm blessed to be friends with a Texan girl since the year 2011. However, if there is one aspect of American society that totally makes me irritated, that would be definitely and without a doubt the crazy and ridiculous measuring system that they use. Again, we still believe that to be just about the correct figure. So Cavendish did well for a first attempt. How about that? So it's 24 zeros basically. The mass of the Earth, it's that of 6 and 24 zeros. I can't believe it. One more time. Long story short, the mass of the Earth is 6 and 24 zeros next to it. How about that? How is that for a big mass of a planet? How fascinating is that? Thank you very much, Mr. Asimov. That was the lesson of today in today's episode of Astronomy with Mr. Asimov. Thank you, Mr. Asimov. I appreciate your knowledge, and I would like to thank you very much for your contributions to science fiction, to literature, and of course to the education of millions, because there is nothing more convenient than a good, nice, smart person who is willing to dumb down all of these complex concepts for ordinary people like me and any person watching this video. Thank you so much, have a wonderful evening, and I'll see you hopefully in another video. Farewell, brave new world.